हेलो।
हेलो।
हेलो सर, गुड आफ्टरनून।
गुड आफ्टरनून। आवाज आ रही है?
जी सर जी।
ओके। हेलो। हेलो। Yes. Good afternoon, students. I hope you are all are well at home. Let's start our next topic, that is micro operation. As we discussed in the previous lecture, what is micro operation? Micro operation is operations like addition, subtraction, multiplication. Okay, these operations which are performed on data which is stored in the register. So here in the last lecture we have discussed two type of operation. One is arithmetic operation, and second is logical operation, and the third one is next operation is shift operation. This shift operation we will do today, and before starting shift operation I will just give you one example of arithmetic and logical operation. Okay, so arithmetic operations like addition, subtraction, increment, decrement. In this operation we have given, suppose we have a register R. It is of 4-bit register. Let us suppose it is 4-bit register. This means register R can store 4 bits of data in binary form. Let us suppose we have a 1, 0, 1, 0. Okay, this is R1 register. If we want to perform add operation, so for adding two numbers, this means we need two operands. We need two numbers. One number is stored, this 1010 stored in R1 register, and second number R2, second register R2 which has 1101. Okay, now we have to add the content of these two registers and store the result in R3 register. Okay, so how we perform addition? I have told you in the last lecture, 101 is equal to 1, 101 equal to 1, 10 equal to 1, 10 equal to 1, and 11 equal to 0, and 1 is carry. This is carry bit, and our result is this 0111. This is the addition of two numbers. Addition of two numbers. If I want to increment R1 register, if I want to increment the content of R1 register by 1, then how we perform this operation, increment operation? I just write the content of R1, add 1, and add 1, 1011101. Okay, this is the increment operation. This is how we perform increment operation. Now let us suppose if you want to subtraction R1 minus R2. In this operation we want to subtract the content of R2 register from the content of R1 register. Now suppose R1 register has number this 1010, and R2 register we have a number 1101. Okay, and subtraction, we perform subtraction by 2's complement. By 2's complement, we perform subtraction by 2's complement. How we perform subtraction? Firstly, what we do, firstly we number that we want to subtract from R1. we perform 2's complement on R2. This number I want to subtract from this number. So we perform 2's complement on this number. How 2's complement perform? Firstly, we perform 1's complement and then add 1 in the result. That is our 2's complement. Like this. Now, suppose this is R2 register. We perform 1's complement on this number. That is 1's complement means 0 to 1, 1 to 0. 1 converted into 0 and 0 converted into 1. So 1 converted into 0, 1 converted into 0, 0 converted into 1 and 1 converted into 0. So this is 1's complement. This is 1's complement. Okay, now add 1 in this number. We add 1 in this number. Okay, 1, 0, 1, 1, 1, 0, 0. This is 2's complement. Now add this number with R1. So how we perform subtraction? R3 is equal to R1 plus R2 1's complement plus 1. Okay, in this way we can perform in this way we can perform subtraction. Now this number is added with R1 number. The result what we get, that is the subtraction. Okay, in this way we can subtract our two numbers. Okay, so here write 0, 0, 1, 1. Add these two numbers 1, 0, 1, 1, 1, 0, 1 carry 1, 0, 1, 1, 0, 1. Okay, 1, 0, 1. This is our result. Okay, this is our subtraction. And remember one thing, in COALP we always consider binary numbers, or you can say hexadecimal number. Binary number or hexadecimal number. What is hexadecimal number? Hexadecimal number means 0 to 15. These are hexadecimal numbers. Unmute करो तमन्ना.
Yes, sir. I have a doubt.
Yes.
Sir, while performing subtraction, we
Okay.
are to do R2 1's complement, then 2's complement. Always.
Yes, always. देखो इसमें होता क्या है, सब्ट्रैक्शन करते हैं बाय 2's complement के साथ. हमने क्या करना, R2 नंबर को R1 से माइनस करवाना है, तो हम क्या करेंगे, R2 नंबर का 2's complement करेंगे. तो हाउ वी परफॉर्म 2's complement? हमेशा होता है पहले 1's complement होता है, 1's complement में प्लस 1 करते हैं, वो 2's complement होता है.
Yes, sir.
ओके, इस तरह से हम 2's complement परफॉर्म करते हैं. और जो रिजल्ट आएगा 2's complement परफॉर्म करने के बाद, जो हमारा रिजल्ट होगा 1 ऐड करने के बाद हमारे पास 2's complement आ जाएगा. उस रिजल्ट को हमने R2 के साथ क्या कर देना है, ऐड कर देना है. दैट इज आवर,
मतलब जैसे हमें R1 रजिस्टर दिया होगा और R2 रजिस्टर दिया होगा, तो
Yes.
हमने डायरेक्टली सब्ट्रैक्शन नहीं करनी R1 माइनस R2. सबसे पहले R2 का हमने कॉम्प्लीमेंट करना है 2's.
यस यस, पहले हम R2 का 2's complement करेंगे, उसके बाद उसको R1 के साथ ऐड कर देंगे.
ओके सर, थैंक यू.
दैट इज आवर सब्ट्रैक्शन. ओके.
यस सर.
Okay. And increment operation, that is also easy, just to add plus 1 to the number, that is the increment. Okay, वो हमारा increment हो जाएगा. In this way you can perform various arithmetic operations. Okay, next if you want to perform logical operation, in the same way you have two numbers and you have to perform logical operation. For example, logical and, logical or, logical not. Not means 0 to 1, 1 to 0. That is not operation. Logical and, logical or. Logical and में क्या होता है, multiplication होती है, और में plus होता है. Okay. Logical and का मतलब क्या होता है, if we have two number two same numbers, the result is true. Okay. If we have 0, 0, sorry, if we have 0, 0, result is 0 with AND operation. If we have 0, 1, तभी हमारा result 0, 1, 0, we have 0, 1, 1 is equal to 1 in AND operation. In AND operation. If we have same two numbers, then we have one output. If either of the two is 0, the output is 0. Okay. In this way, we can perform logical operation. And 0, 1 is 0, 0, 0. If either of the number is 1, the result is 1 in case of OR. Okay. Let's take an example. For example, if we have a register of 4-bit register, suppose 1, 0, 1, 0, and this is first number and second number is 0, 1, 0, 1. This is our second number. What will be the output by using AND operation? A and D AND operation use करके output क्या आएगी? बताओ. What will be the output? What will be the output? Unmute Manpreet.
Sir, 0, 0, 0, 0.
Yes. 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. This is our output. Okay. Okay. So in this way, if you have OR operation, same number, by using same number, perform OR operation. What will be the output? What will be the output? 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1. This is the output of OR operation. Okay. Yes, Inderjeet, unmute yourself.
यस सर, वही पहले का आंसर बताना था मुझे.
Okay, okay, ठीक है. Okay, so these are the arithmetic operations and logical operation. Now, next is the important, that is shift operation. That is shift operation. What is shift operation? Next micro operation is shift micro operation. So what is shift micro operation? As the name of micro operation, that is shift. We have to shift the number of registers by one either to the left or either to the right. We have to shift one number either to the left or to the right. Let us suppose if you have a register R, this is register R, which is a 4-bit register. It is a 4-bit register. 0, 0, 1, and 1. Okay. So in shift register, we can, in shift operation, we can shift our numbers either to the left by 1 bit or to the right by 1 bit. Okay. So in shift micro operation, this is the concept of shift. Okay. It is a serial data transfer. It is a serial data transfer by 1 bit, either to the left or to the right. Okay. Shift micro operation is of 3 types. It is of 3 types. It is 3 types. First type is logical shift. Logical shift. In logical shift, we just shift the numbers by 1 bit to the right or to the left. In this case, if we consider, if we want to perform left shift, logical left shift, logical left shift. In this case, left shift means this way. Okay, in this way. In this means the first position bit number. This is the position 0, 1, 2, and 3. This is the representation, how the bits are represented in the register. Okay, the first bit is represented by word digit 0, 1 is represented by 1, next bit is represented 2 and 3 and so on. So the first number, ये वाला जो है, if we want to perform logical left shift, this number is shifted to the left by 1 bit, and in this position we insert 0. We insert 0 at this position, and this number is shifted to this position, and this number is shifted to the next position, and this number is shifted to the next position, and the last bit, the last number is discarded. Discarded. Okay, this is left shift. And what will be the output? The output is 0, 1, 1. After performing logical left shift, what will be the output? This is the output, 0, 1, 1, 0. 0 is inserted at first position, and next bits are shifted to the left by 1 bit, and the last bit is discarded. Okay, in this case we have to lose our data like this. क्या कि लास्ट जो बिट है वो उसको हम डिस्कार्ड कर देते हैं और फर्स्ट बिट पोजीशन के ऊपर 0 इंसर्ट कर देते हैं. Okay, this is the logical shift, and the symbol and you can say register transfer language for shift, logical shift, SHL means logical shift left, and SHR, that is logical shift right. If we have a register R and we want to perform logical shift on register R, how we represent this? We represent this. If you want to perform logical shift left, then you write SHLR. SHR R. Okay. What does it mean? This means shift the content of our register to the left. Okay. In logical shift, in this operation, we shift the content of our register, logical shift our register to the right by 1 bit. Okay, the example is this. Okay, if you want to transfer data from shift data to the right side, then how you perform operation? How will you perform operation? What will be the output? What will be the output? This one is out from the register and discarded this bit, and this one is shifted to this, this one is shifted to this, this bit is shifted to this, and here we insert 0. We always insert 0. Okay, so what will be the output? 0, 0, 0, 1. This is the output, logical shift right. Okay, any doubt, students? This is logical shift right. Clear? अभी मैंने आपको एक एग्जांपल देनी है, वो you will solve that example. Okay, so the next is circular shift. Next we have circular shift. In logical shift, as we seen that the data, our data is lost, but in circular shift, second type is circular shift. In this shift, our data is not lost, information is not lost, because the information in a register circulates from one end to the other end. Let us suppose if we have a register R, this is our register R, which is of 4 bits. Suppose it is of 4 bits, and we have data 1, 0, 0, 1. Okay, this is our information, this is our number 1, 0, 0, 1. Okay, and we want to perform circular shift. In circular shift, our information is not lost, it circulates from one end to the other end. If you want to perform write operation, if we want to perform write operation, how will it perform? This bit, the first bit is 0, 1, 2, 3. Okay, this is the positions of bits. These are the positions of bits. So this, the first bit, if we want to perform write operation, तो ये इधर को हमारी shift करेंगी by 1 bit. So and first bit number 0 is circulate to the other end, position number 3, and this bit is shifted to this bit is shifted to position this, and this bit is shifted to position this. And what will be the output? The output is this one is 1 here, 1 is here, 1 1 0 0. This is our output. Okay, in this you can see there is no loss of information. We just rotate our bits from one end to the other end. Okay, easy. Okay, next if we have circular shift left, if you want to perform circular shift left operation, what will be the output? What will be the output? Hurry up. Left shift. This means this. What will be the output? Yes, Manpreet, unmute.
Sir, the output is 0011.
0
0011. So वो 1 पीछे चला जाएगा and 00 आगे हो जाएगा and
in this way.
No sir, 0011. 0 पहले नहीं आएगा सर. सर जो थर्ड पोजीशन पे 1 है वो पीछे चला जाएगा ना सर?
ये वाला?
हाँ जी सर, ये पीछे चला जाएगा एंड पे.
हाँ जी. हम तो
तो
कौन सा कर रहे हैं हम? शिफ्ट
लेफ्ट शिफ्ट सर.
लेफ्ट शिफ्ट इस साइड को.
हाँ जी सर.
है ना?
सर हाँ जी.
दिस वन ये यहाँ पे.
हाँ सर, ये जो थर्ड पोजीशन पे है वो सर लास्ट में चला जाएगा.
Yes.
यहाँ पे
0 0 1
1. Yes sir.
Clear? Okay,
जी
students.
सर.
In this way, okay, Manpreet. In this way, you can perform circular shift. And how you represent circular shift? And the symbol for representing circular shift operation is CIR, which is circular shift right, and CIL, that is circular shift left. And suppose if we want to perform operation on register R, okay, circular shift, if I write like this, this means perform circular shift right on the content of register R. Okay, if we write like this, this means perform circular shift left on the content of register R. Okay, clear students? Okay. Next, the most important shift, that is arithmetic shift. बहुत important है arithmetic shift. Arithmetic shift is of two types. Yes, Inder, unmute yourself.
Sir, please unmute.
हाँ जी, बोलो.
सर अनम्यूट ही रखो सर, और फिर आंसर देना ਹੁੰਦਾ ਤੇ
एक्चुअली पता क्या है, मैं इसलिए अनम्यूट करूँगा, डिस्टर्बेंस कई बार हो जाती है बहुत ज़्यादा.
सर ਅਸੀਂ ਆਪਣੇ ਵੱਲੋਂ अनम्यूट कर लेने हैं.
सभी को
यस सर.
देख लो,
नहीं
कोई
सर,
डिस्टर्बेंस हुई जहाँ कोई भी किसी ने किसी तरह की प्रॉब्लम क्रिएट की, तो सबको इसके लिए फिर प्रॉब्लम होगी. फिर बोलते नहीं हो.
यस सर. मैं तो सर
देखो, आप अकेले
सर,
की बात नहीं है ना, कोई बीच में ऐसे ही. हु इज नितिका नैब? Okay, students, if you have any problem, raise your hand. Okay, I will unmute you. Yes. Okay. Next is a logical shift. हमने कर लिया है, circular shift like this. Okay. And these are the list of shift micro operation. The first is SHR, that is logical shift left. Next SHR, logical shift right. Then CIL, circular shift left. CIR, circular shift left. ASHL, arithmetic shift left. And ASHR, arithmetic shift right. So we are discussing about arithmetic shift. It is of two types. It is of two types. One is arithmetic shift left, and second is arithmetic shift right. Arithmetic shift left and arithmetic shift right. Okay, so let's start first arithmetic shift. Let us start first arithmetic shift right. Arithmetic shift right. Arithmetic shift right. Okay. In arithmetic shift operation, remember one thing. We have a number. Let us suppose we have number 1 0 1 1 0 1 1 0. We have 8 bits. Okay. This is our 8 bit. This is our, suppose it is our data. Okay. The last bit of the number, the most significant bit means the last bit, bit number 7. This is the numbering of bits 0, 1, 2, 3, 4, 5, 6, 7, 7. Suppose it is 8-bit register and this is our data. It is 8-bit register. This is our data. 1 second. Okay, suppose this is our number, which is of 8-bit number, and the positioning of these numbers represented as 0, 1, 2, 3, 4, 5, 6, and 7. Okay, and listen carefully and remember one thing, the last bit, most significant bit, this is called most significant bit. Bit number 7 is called most significant bit, most significant bit, and bit position number 0 is called least significant bit. And remember this thing. Okay, the most significant bit, bit number 7, represent the sign of a number. Represent the sign of a number. This means that this number, it may be a positive number or it may be a negative number. What is this number? Is it a positive number or is it a negative number? ये हमें पता चलता है last bit. If the last bit is 0, if the last bit is 0, then it is, this number is positive number. If the last bit is 1, this means it is negative number. So this means this is our negative number. If it is 0, this means this number is positive number. If it is 1, this means it is our negative number. Okay, so we are performing now. We will start arithmetic shift right. Arithmetic shift right means we shift the number to the right position by 1 bit. So if we shift the numbers to the right, the first bit, this one, is out from the register and discarded. Out from the register and discarded. And another one thing, the last number, the last bit it should always be same. If it is after shift it should be always same. ये हमेशा ही सेम होना चाहिए. हमारे नंबर का साइन चेंज नहीं होना चाहिए. It never be changed sign of a number. If it is like this, it is a positive number because the last most significant bit is 0. So this means it is our positive number. So after shift it always should be positive. After shift ये हमारा positive ही रहना चाहिए. Negative positive to negative, negative to positive नहीं होना चाहिए. Okay. So it is a little bit difficult arithmetic shift. So how we perform arithmetic shift right in arithmetic micro operation? Okay, listen carefully. The last bit, if we want to perform shift right operation, all the bits move to the right by 1 bit, and the first bit is out from the register and discarded. And here this bit is moved to this location, this bit is moved to the next, and last bit it in arithmetic right shift ये यहाँ पर भी रहेगी और आगे भी मूव कर जाएगी. It move to the next position and remain its own position. Okay, ये last bit जो है अपनी next position के ऊपर भी जाएगी और ये 7th position के ऊपर भी रहेगी. So after performing arithmetic right operation, what will be the output? What will be the output? 0, 1, 1, 1, 0, 0, 1, 1, 0, 0. This is the output. This is the output of arithmetic shift right. Okay, remember one thing in arithmetic operation, in arithmetic shift right, ये easy है थोड़ा सा arithmetic left shift. इसमें क्या होता है जो last bit, most significant bit which represents the sign bit of the number, if it is 0, this means the number is positive. If it is 1, the number is negative. And in arithmetic shift right, it moves to the next position and remain its own position. आगे भी मूव करेगी और ये अपनी पोजीशन के ऊपर भी रहेगी. Let us suppose if I give you a number, if you have a number 1, 1, 1, 0, 1, 1. Let us suppose 4-bit number. What will be the output by using arithmetic shift right? What will be the output? Arithmetic shift right, ASHR. What will be the output by using arithmetic shift? Yes, Manpreet.
Sir, the output is 1101.
1101. Yes. 1101. You can send me a message. Okay.
Okay, sir.
Okay. Yes, the output will be 1101. Okay. I hope आप सबको पता चल गया होगा कि what is arithmetic shift right. Okay, the next is arithmetic shift left. It is a little bit tricky how to perform arithmetic shift left. And ध्यान से सुनना इसको बहुत. Arithmetic shift left. Hello? Hello? Hello, yes. Okay, the next is arithmetic shift left. So let us suppose if we have 8 bits, let us suppose we have 8 bits, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let us suppose we have 8-bit register and these are 8 bits, and how we represent 8? 0, 1, 2, 3, 4, 5, 6 and 7. The most significant bit is the sign bit. Okay. Now how we perform left operation? वैसे तो ये easy है. Left operation हमने क्या करना है? इस तरह, in this way. Shift the number here, insert 0, and this bit is shifted to the position number 1, and this bit is shifted to this is shifted to this is shifted to this is shifted to this, and this and this, in this way, and the last bit is out from the register and discarded. Okay, in this way we will perform arithmetic shift left. Now what happens if these bits are not same? हमने क्या बोला था कि जो लास्ट बिट है it always be same, it always be same. If it is 1, it should be 1 after performing left shift. If it is 0, it should be 0 after performing arithmetic shift left. Okay, so suppose if you have a number 0 1 1 0 0 1 0 0. Now perform arithmetic shift left. तो हमारे पास जो आउटपुट आएगी, what will be the output? 0 0 1 1 0 0 1 0. This will be the output. In this case, we have no problem because the last two bits, bit number 6 and bit number 7, both the bits are same. So हमारा जो नंबर है वो चेंज नहीं हुआ, हमारा नंबर पॉजिटिव का पॉजिटिव ही रहा. But if what happen if the bit number 6 is 1 and bit number 7 is 0, then there is a problem. Then there is a problem. Then what will be the problem? No, this one. After performing left operation, we have an answer like this. Okay, now the number is converted from positive to negative, and this is not acceptable. मैंने आपको क्या बोला था कि अगर हमारा नंबर पॉजिटिव है तो it should be positive. If it is negative, then it should be negative after performing the arithmetic shift. Now this is called overflow. This situation is called overflow. This situation is called overflow. What is overflow? If both the bit number 6 and bit number 7 is not same, both bits are not same, then that situation is called overflow. उसको हम क्या बोलते हैं? Overflow बोलते हैं. And how we check it कि overflow आया है कि नहीं आया है? For that purpose, we use a flip flop that is called V flip flop. V flip flop. If it is 0, then there is no overflow. If it is 1, there is overflow. No overflow. If it is 1, then overflow. Then there is overflow. Now, for checking if there is overflow or there is no overflow, we use a XOR gate. 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 XOR gate is performed on last two bits. If both are same, if both bits are same, if it is 0, this is 0. What will be the output of XOR gate? If both numbers are same, both inputs are same, either it is 0 or 1, 1, same bits, then what will be the output of XOR gate? 0, 0, 1, 1. What will be the output? That is false. Means 0 output. If these are 0 1 and 1 0, the output is 1 of XOR gate. You will study it in BCLD subject. Okay, मैं ज़्यादा नहीं इसमें आपको बताऊंगा क्या होता है. You just remember if the both inputs to the XOR gate are same. अगर दोनों inputs same है तो output is 0. Output will be 0. If both the bits are different to the XOR gate, if it is 1 0 or 0 1, the output of XOR gate will be 1. If the value of R is equal to 1, if the value of B flip-flop is equal to 1, this means there is overflow. What is the meaning of overflow? This means the last two bits, bit number 6 and bit number 7 are not same. अगर दोनों same नहीं है, then we need sign reversal. We need sign reversal after performing arithmetic shift left. Okay, clear? Let us suppose if this is our data. Now we want to perform arithmetic shift operation on this data. So this bit is moved to the position number 1, and here we insert 0. The output will be 0 0 1 1 0 0 1 0. This will be the output. Okay, after performing arithmetic shift left, there is no problem, there is no overflow, because both the bits of XOR gate are same. Both the inputs to the XOR gate same. If both the inputs are same to the XOR gate, the output will be 0. So V flip-flop is equal to, here we get 0, and this 0 move to the V flip-flop, and the output of V flip-flop is 0. If V is equal to 0, then there is no overflow. This means our number is positive. पहले भी हमारा positive था, और after arithmetic shift left, it is also positive. Okay, there is no problem. Now suppose if it is 1, if the bit number 6 is 1, then what will be the output? What will be the output? Now we have 1 0 to the XOR gate, 1 0 to the XOR gate, and output will be 1. I told you, if the inputs to the XOR gate are not same, 1 0 0 1, then output will be 1. Remember this thing. अब जस्ट इतना याद रखो कि अगर XOR गेट के दोनों इनपुट्स अलग हो तो आउटपुट 1 आती है, अगर सेम है तो आउटपुट 0 आती है. ओके, नाउ व्हाट विल बी द आउटपुट ऑफ V flip flop? It is also 1. If it is 1, if V is equal to 1, then there is overflow. Overflow means last two bits are not same. इसका मतलब क्या है कि हमारा नंबर वो क्या हो गया, चेंज हो गया. पहले पॉजिटिव था, फिर क्या हो गया, नेगेटिव. देन व्हाट विल बी द आउटपुट? The output will be 1 1 0 0 1 1 0 0. This will be the output. Now here we have 1, but in actual data we have 0. After performing arithmetic shift left, it changed from 0 to 1. No, what will be? हमने क्या बोला था, लेकिन हमने क्या बोला था कि ये नंबर क्या रहना चाहिए, सेम. Positive to positive, negative to negative. So here we need sign reversal. Here we need sign reversal. In sign reversal, we change the number to its original number. Means 0 1 0 0 1 1 0 0. And remember one thing, you will write both the answers. पहले जो actual में आंसर आया है after performing left shift, arithmetic left shift, वो वाला. If overflow, there is overflow, you have to need sign reversal. Sign reversal करके ही आपने आंसर लिखना है. क्लियर? ये बहुत इंपॉर्टेंट है फॉर द एग्जाम पॉइंट ऑफ व्यू. इसको एक बार देखना, समझना. अगर आपको कोई डाउट हो तो यू कैन डिस्कस विद मी. ये देखो arithmetic slide, in the slide arithmetic shift right, the last bit rn minus 1 is moved to the next position and remain in its own position. Here that is a left shift, जो मैंने अभी बताया वो सारा कुछ इसमें लिखा हुआ है, वही है. देखो the last two bits are inserted and we check what will be the value of R flip flop. Okay, what will be the value of R flip flop? It is what will be the value of R flip flop? Okay. If it is 0, then there is no overflow. If it is 1, there is overflow. Okay. If you have any doubt, you can ask me after the class. Okay. Now I am going to launch poll 1. Yes, Manpreet, unmute yourself.
सर एक डाउट ਸੀ ਸਰ ਅਗਰ ਜੇ
Yes.
7th ਪੋਜੀਸ਼ਨ ਤੇ 1 ਹੁੰਦਾ ਤੇ 6th ਪੋਜੀਸ਼ਨ ਤੇ 0 ਹੁੰਦਾ ਸਰ ਫਿਰ ਕਿਸ ਤਰ੍ਹਾਂ ਸ਼ਿਫਟ ਕਰਨੀ
फिर भी क्या था, फिर भी ना आपका नंबर चेंज हो गया.
ਹਾਂਜੀ ਸਰ
If it is 1, if it is 0, firstly the number is negative. After performing left shift, it
जी,
is
sir.
0. No, it is
जी सर
positive number. Then we also need a sign reversal. फिर भी हमें
सर
sign
ਉੱਥੇ 1
reversal
ਲਿਖ ਦੇਣਾ
चाहिए.
ਸੀ ਸਭ ਤੋਂ ਅੱਗੇ
Yes, yes. पहले जो एक्चुअल में आता है वो लिखना है, ठीक है. आफ्टर परफॉर्मिंग अर्थमेटिक शिफ्ट लग जो आंसर आता है वो लिखना है. अगर तो ये बिट चेंज हो
लास्ट
जाती है,
डिजिट चेंज कर देना है
हाँ, यस, फिर देन वी नीड साइन रिवर्सल. ओके.
ओके सर थैंक यू सर
Now I am going to launch poll 1. And you have 5 minutes for it. दीपेश, क्या हुआ? साइलेंट अच्छे नहीं लगते बच्चे? ओके, सभी ने पोल कर लिया? आई एम गोइंग टू एंड पोल. All done? Okay, students, I'm going to end poll. Okay, and the next topic is arithmetic logic shift unit. Arithmetic logic shift unit. ओके, आपको मैं ये पोल का रिजल्ट जो है वो आपको ग्रुप में डाल दूंगा. ठीक है, आज नहीं कल डालूंगा, कल डालूंगा आपको ग्रुप में. हमारा जो COALP का ग्रुप है ना, उसमें डाल दूंगा. ओके, now the next topic is ALU. The next topic is ALU. ALU, arithmetic logic shift unit. Arithmetic logic shift unit. Okay, as we know what is the meaning of arithmetic logic shift unit. This unit perform various arithmetic operations, logical operations, and shift operations. Okay, this unit perform arithmetic operations, logical operations, and shift operations. Okay, तो आज सबको हमें पता भी होगा कि what does arithmetic logic shift mean. This unit perform various arithmetic operations, logical operations, and shift operations. But with this topic, we just consider limited operations. Here we can only consider 8 arithmetic operations, 4 logical operations, and 2 shift operations. 2 shift operations. Here we have a diagram. You just see the diagram on slide. This is the diagram. In this diagram, we have three units. The first is arithmetic circuit, which perform various arithmetic operations. Second is logic circuit, which performs various logical operations. And we have two shift operations. One is a shift right and second is shift left. It is journal shift. Okay. So ये नहीं है कि ये circular है या arithmetic है. It's a journal shift. Shift the bit to the right or shift the bit to the left. Okay. And we have four S0, S1, S2, S3. These are the four selection variables. These are selection variables. Ci is the carry. Ci is the carry. Ci plus 1 is the carry to the next bit. Okay. Here we have a multiplexer, 4 into 1 multiplexer. Multiplexers which takes n inputs and give one output. N inputs, it is a 4 into 1 multiplexer. This means it will take 4 inputs. One is from DI, second from EI, third and fourth from the shift operation. Okay. It takes 4 inputs and it will produce one output. Clear, students? Okay. Here we have BI, AI and BI in the inputs to the logic circuit, and same inputs to the arithmetic circuit. Okay, listen carefully, students. Arithmetic logic shift unit. This unit performs various arithmetic operations, logical operations, and shift operations. Clear? In this diagram, we have arithmetic circuits which perform arithmetic operations like addition, subtraction, increment. Second is we have logic circuits which perform logical operations, for example, logical and logical OR operation, and two inputs which performs shift operation, shift right and simple shift left operation. Clear? And one is a multiplexer, that is of 4 into 1 multiplexer, which takes n inputs and gives one output. It is of 4 into 1 multiplexer. This means it can take 4 inputs and it will produce one output. Okay. Here we have 4 inputs. One is DI, second is EI, third SHR, fourth SHLA. 4, 0, 2, 3. These are the inputs and one output FI. Okay. Here S0, S1. So firstly, you will see the selection variables S2 and S3. S2 and S3 selection variables are used to select a particular circuit. Either it is arithmetic circuit, logical circuit, or shift circuit. Clear? S2 and S3 selection variables are used to select a particular circuit, particular unit, arithmetic unit, logical unit, or shift unit. इन तीनों में से कौन सा यूनिट select करना है? This will be determined by S2 and S3. Now, let us suppose by using selection variables S2 and S3, we have select the arithmetic operation. Arithmetic circuit, sorry, arithmetic is circuit. Now, in arithmetic circuit, we have total 8 operations. For example, it may be a add, subtract, increment, decrement, yeah, increment with borrow, increment with complements, like this. Now, S0 and S1. S0 and S1 selection variable will select a particular operation. Okay. Now, logic operation. Okay, students. Now the next, if you want to select arithmetic circuit, the selection variables S2 and S3, it should be 0, 0. See in the table S2 and S3. If S2 and S3 two selection variables are 0, 0, till यहाँ तक. Okay, total 8 operations है यहाँ तक. Okay. So this means we have arithmetic operations. कौन सा arithmetic operations है? That can be determined with S0, S1 and C in bit. Okay, if S3, S2 is equal to 0, 0, this means arithmetic circuit is selected, and which operations is performed from arithmetic circuit we determine from S0, S1. If S0, S1, 0, 0, 0, then we have transfer A. This means transfer the content of A to the register S. If S1, S0, C and in 0, 0, 1, then we will perform arithmetic increment operation. Increment operation. देखो S2 और S3 0, 0 है. कहाँ तक? जहाँ तक 8 ऑपरेशन अर्थमेटिक है तो ये 0, 0 ही रहेंगे. तो उन 8 में से कौन सा ऑपरेशन परफॉर्म करना है, सिलेक्ट करना है, वो हम डिटरमिन करते हैं S0, S1. ओके. Now if S1, S2 is equal to 0, 1, 0, then we will perform add operation. 0, 1, 1, add with increment. 1, 0, 0, subtract with borrow. 1, 0, 0, 1, 1, 0, 1, subtraction. 1, 1, 0, decrement. And 1, 1, 1, transfer A. Again transfer A. Now if S3, S2 is equal to 0, 1. If the value of selection variable S3 and S2 is 0, 1, then we will perform logical operation from the logical circuit. And which operation we are performing from the logical circuit? That is determined by S1, S0, selection variable. C in the G-Sync, C in is a carry. If we want to add two numbers in arithmetic operations, we have generally we have a carry bit. Okay, so C in represent carry. Clear? Carry bit को represent करती है C in. Okay, so next S3, S2, if we have 0, 1, this means we are performing logical operations. In logical operations, there is a no carry. In logical operations, there is no carry. So it marked as cross. So it's marked as cross. Okay, इसको हमने cross से mark कर दिया क्योंकि logical में carry नहीं होता है. So if S1, S0, 0, 0, we will perform AND operation. 1, 0, we will perform OR operation. Sorry, 0, 1, we will perform OR operation. 1, 0, we will perform XOR operation. And 1, 1, we will perform complement A operation. Okay, now we have only two remaining operation, that is shift left, shift right and shift left. If S3, S2 bits 1, 0, if S3 1, S2 is 0, then we will perform shift right. If it is 1, 1, we will perform shift left. Easy है इस टेबल को याद करना. S3, S2, 0, 0 for arithmetic circuit, 0, 1 for logic circuit, and 1, 0 and 1, 1 for shift right and shift left. एक बार सर्किट सिलेक्ट कर लिया, उसमें से कौन सा ऑपरेशन परफॉर्म कर रहे हैं, दैट इज डिटरमिन्ड बाय S0, S1, S0 सिलेक्शन वेरिएबल. क्लियर? तो दिस इज तमन्ना, ये जो टेबल है ना, ये डायग्राम तो आपको करना ही पड़ेगा. You have to give अगर आपसे पूछा तो है डिस्कस अबाउट अर्थमेटिक लॉजिक शिफ्ट यूनिट विद डायग्राम एंड टेबल. You have to give the introduction about arithmetic logic shift unit. What is the purpose of arithmetic logic shift unit? It is used to perform various arithmetic operations like add, subtract, increment, and logical operations like logical AND, OR, and various shift operation. Okay, पहले ये introduction देनी है. Then you have to explain little about this diagram, and then you have to draw this table and remember these values. Maybe देखो प्रतीकजोत सिंह देखो आ सकता है, ये तो डिपेंड करता है ना एग्जामिनर के ऊपर, ठीक है ना. तो इजी है, टेबल को याद करना कोई डिफिकल्ट नहीं है. यू हैव टू S3 S2 इज इक्वल टू 0 0 मीन्स अर्थमेटिक ऑपरेशन, 0 1 मीन्स लॉजिकल ऑपरेशन, एंड 1 0 1 1 मीन्स शिफ्ट राइट एंड शिफ्ट लेफ्ट ऑपरेशन. इजी है, ठीक है. So this is about arithmetic logic shift unit. Now we have next topic is memory transfer. Memory transfer. Memory transfer. What is memory? What is memory? Anybody? Yes, Indrajit. Hello. Indrajit, unmute yourself.
Sir, storage capacity.
आवाज नहीं आ रही साफ, आवाज क्लियर नहीं आ रही. इंद्रजीत आवाज क्लियर नहीं आ रही आपकी.
Sir, storage is known as memory.
Storage, store the data. For storing?
Sir, storage. Yes, sir, storage capacity in which we store the data.
Okay, yes,
is known as memory.
yes, yes. Okay, what is a memory? Memory is a combination of cells which are used to store data. ये हम suppose ये हमारी memory है. This is our memory. This is our one cell, and one cell is stored to is used to store a word, or it may be a 4-bit or 8-bit. 8-bit. Let us suppose if we want to store 8 bits, this means we can store 1 byte of data. Okay, 1 byte of data in one cell. In one cell we can store 1 byte of data. Each word is accessed by address of that cell. Okay, each word is accessed by address of that cell. Okay, so this means we can store data to the memory, or we can read data from the memory. Okay, what is the purpose of memory? Memory is used to store the data, and we have two operations which we can perform on memory. One is read, second is write. Read means read the data from the memory. From the memory we can read the data. If we want to perform write operation, this means we are going to write new word to the memory by using write operation. Clear? Okay, we have two memory operation. One is read operation, second is write operation. Read operations means we want to read the data from memory. Write operations means we want to new word on the memory. Clear? These two operations. And for both operations, for both either if it is a read operation or write operation, we need a memory address. we need a memory address from where we want to read the data. If we are performing read operation and we need memory address on that उस जिस लोकेशन के ऊपर हम डाटा राइट करना चाहते हैं वो भी लोकेशन की हमें वो भी एड्रेस हमें चाहिए हो, ठीक है, फॉर द पर्पस ऑफ राइट ऑपरेशन. ओके, दिस इज अबाउट मेमोरी ट्रांसफर. कैसे हम मेमोरी में डेटा रीड कराते हैं, राइट करते हैं. फॉर what are operations of memory? One is read operation, second is write operation. Clear? And we need a memory address for reading the data from memory, and we need a memory address for writing the data on a memory. Clear? तो इसको याद कर लेना. तो ये मैं आपको नोट्स में सेंड कर दूंगा. ये एक चैप्टर फर्स्ट यूनिट जो था हमारा, दैट इज रजिस्टर ट्रांसफर लैंग्वेज, ये कंप्लीट है. ठीक है. इफ यू हैव एनी डाउट, अब इस पूरे चैप्टर के नोट्स आई विल सेंड यू इन योर ग्रुप. ओके, कोएलपी का जो ग्रुप है उसमें अब मैं ये सेंड कर दूंगा. कल सेंड करूंगा, आज भी कल सेंड करूंगा. ये पीपीटी भी आपको मैं मेल कर दूंगा और पीपीटी पोर्टल के ऊपर भी होगी. ठीक है. और द हैंड रिटन नोट्स आई विल आल्सो सेंड दीज नोट्स इन योर ग्रुप बाय टुमारो. क्लियर? ओके. And if you have any doubt regarding this chapter RTL, you can ask me. And once again, I want to tell you, this is not an easy subject. It is a difficult subject. So you have to, इसको क्या है कि साथ साथ में पढ़ना पड़ेगा आपको. Okay? If you have any doubt, immediately you can ask me. Okay? कोई भी डाउट है तो आप मुझे से पूछ सकते हैं. Clear? ठीक है. So, okay, the next is have you students any doubt? No? Okay, let's say you have a example. अभी पता चल जाता है डाउट है कि नहीं है. Suppose you have a question. If let us suppose we have registers AR, BR, CR and DR. We have 4 registers AR, BR, CR and DR. All the registers of 8-bit register, and their values are AR is equal to 11110010. B की वैल्यू है 1111 and C is equal to 10111001 and DR is equal to 11101010. Okay. Now we have 4 registers AR, BR, CR and DER. Now you have to perform operations. The first operation is AR plus BR. First operation is the addition operation. Second operation is CR and DR. Second operation is the AND operation. Third one is BR plus 1. Fourth is AR minus CR. You have to perform these 4 operations. One is first operation is addition. Add the content of register AR with the content of BR register. Second, perform logical AND operation with the CR register with the DR register. Third one operation is the increment operation. Increment the contents of BR register, and next is perform subtraction operation. Now you have to use the updated value of the registers. Okay, now here firstly initially the value of AR register is this, but after performing add operation the value of AR register is changed. So you have to use updated value of AR. Okay, तो क्या है कि AR BR के कंटेंट दोनों ऐड करने और रिजल्ट AR में ही स्टोर करना है. सो AR रजिस्टर के कंटेंट्स चेंज हो जाएंगे, अपडेट हो जाएंगे, ठीक है ना, रिप्लेस हो जाएंगे प्रीवियस के साथ. सो यू हैव टू यूज अपडेटेड वैल्यू ऑफ द रजिस्टर. यस तमन्ना, अनम्यूट योरसेल्फ. तमन्ना.
यस सर.
Yes.
सर हमने AR की जो पहले प्रीवियस वैल्यू है वो फर्स्ट पॉइंट में आके हमारी चेंज हो जाएगी.
बिल्कुल, रिजल्ट उसमें स्टोर होगा पहले.
ओके सर. फिर उसके बाद सर हमने जो फर्स्ट में हमारी स्टोर हुई है न्यू वैल्यू वो हमने फोर्थ में यूज करनी है.
बिल्कुल बिल्कुल, जो न्यू वैल्यू है AR की वो आप यूज करोगे फोर्थ में.
फिर सर फिर से AR की न्यू वैल्यू हो जाएगी उसके बाद चेंज.
यस बिल्कुल, फिर से नहीं हो जाएगी. ठीक है. यस इंद्रजीत. इंद्रजीत तुम्हारी आवाज नहीं क्लियर आ रही.
सर
इंद्रजीत आवाज नहीं आ रही.
सर हमारे पास.
हाँ हाँ
सर इन सेकंड सर सिंबल क्या सिग्निफाई कर रहा है?
दैट इज द एंड ऑपरेशन, लॉजिकल एंड ऑपरेशन.
यस सर.
ओके. हाँ जी स्टूडेंट लिसन, जो कैप बना है CR और DR के बीच में जो सिंबल है दैट इज द लॉजिकल एंड ऑपरेशन. और ओके स्टूडेंट्स, ये आपका होमवर्क है, इसको आपने कंप्लीट करना है. अनदर वन क्वेश्चन इज इफ यू हैव, सो राइट डाउन, if we have a register R and its value is 1 1 0 1 1 0 1 1 0 1. Okay, so firstly perform logical shift. So write down the question. Logical shift followed by circular shift followed by circular shift right, logical shift left followed by circular shift right, followed by logical shift right, followed by circular shift left. ये आपका घर का काम है, तो ये दो आपने कंप्लीट करके मुझे इसका आंसर जो है वो बताना है. सो अगेन आई एम गोइंग टू रिपीट द वैल्यू ऑफ रजिस्टर R is 1 1 0 1 1 1 0 1. Now you have to perform logical shift left followed by circular shift right followed by logical shift right followed by circular shift left. Okay, तो इसको आपने इसको कंप्लीट करना है. Now the next unit is basic computer organization and design. Basic computer organization and design. The next is basic computer organization and design. Okay students, visible है सबको? Okay, the next unit is basic computer organization and design. Basic computer and organization, basic computer organization and design. In this chapter, we will study about what is instruction code, computer registers, computer instructions, timing and control unit, instruction cycle, memory reference instructions, input, output, interrupts, complete computer description, basic design of basic computer, design of accumulator register. Now, in this, the first is instruction code. What is instruction code? Now listen. What we do, we give instruction to the computer. We give the instruction, we instruct the computer that perform a particular operation. Okay, so we give instruction. For example, if we want to perform add operation, we will give the instruction add that to the computer that computer perform add operations between two numbers. हम क्या कहते हैं कि दो नंबर्स के बीच में ऑपरेशन परफॉर्म किया जाए, ऐड ऑपरेशन. ओके, सो instruction code, what instruction is the complete instruction that we give to the computer for instructing the computer to perform particular operation. And if we talk about code, so this means we have what is instruction code. It is group of bits, What is instruction code? Instruction code is group of bits which instruct the computer to perform a particular operation. For example, we have a instruction. For example, we have instruction add AB. This is the instruction of assembly language. Assembly language की ये instruction है. And what is AD is the operation which we want to perform on the content of register A and content of register B. Okay, this is the complete one instruction. If we give this instruction to the computer will what the computer will perform? The computer perform add operations on the register A and B. Okay, this instruction is divided into various parts. We can divide these instructions into various parts. It may be an address part, operation code part. Operation code means operation code that we want to perform, like addition, subtraction, increment, logical and logical OR. These are the operation code. Okay, that we perform on data, that we want to perform on data. That is the operation code. Okay, third, add AB. It is a complete one instruction. And the meaning of this instruction in assembly language, add the content of register A with the content of register B. And here add is the operation code. And this instruction is divided into, this instruction is represented in बिट्स मीन्स 0 1 की फॉर्म में इस इंस्ट्रक्शन को हम रिप्रेजेंट करते हैं 0 1 की फॉर्म में। ओके, सो इंस्ट्रक्शन कोड क्या हो गया? व्हाट इज इंस्ट्रक्शन कोड? इट इज ग्रुप ऑफ बिट्स which instruct the computer to perform a particular operation. Clear? Clear? Next is operation code. Operation means add operation, shift operation, subtract operation, logical operation, logical and, logical or, complement. These are the operations. Okay, these are the operations. If we represent these operations in the form of binary, that is the operation code, and operation code is a part of instruction code. इंस्ट्रक्शन कोड क्या होता है? कंप्लीट इंस्ट्रक्शन होती है जिसके बीच में मैं ऑपरेंड का एड्रेस भी होगा, ऑपरेशन भी स्पेसिफाई किया होगा, वो हमारी एक ऑपरेशन होगा, इंस्ट्रक्शन कोड होगा. बट व्हाट इज ऑपरेशन कोड? ऑपरेशन कोड इज द पार्ट ऑफ इंस्ट्रक्शन. सो व्हाट इज ऑपरेशन कोड? ऑपरेशन कोड इज ग्रुप ऑफ बिट्स which perform operations like add, subtract, shift, clear, etc. These are the operations which are performed on data. Let us suppose we have two registers, register A and B. इसमें कोई suppose करो कोई ना कोई value है 0 1 0 1 1 0 1 0, and we want to perform operation on these two registers. We always perform operations on these registers. Okay, so what is instruction code? Instruction code is the group of bits which instruct the computer to perform particular operation. Okay, and what is the operation code? Operation code is the group of bits and it is the part of instruction code, and it is the group of bits which perform operations like add, subtract, shift, clear, etc. on the data which is stored in the registers. Okay, so these are what is instruction code and what is operation code. Now suppose, now remember one thing, our instructions or program. What is program? What is program? What is program? Anybody? Inderjeet, unmute yourself.
Sir, program is a set of instructions.
Yes. ठीक है आंसर. Yes, program is set of instructions. Program is set of instructions. ठीक है. एक होता है हमारा डेटा, एक होता है इंस्ट्रक्शन. एक होती हमारी क्या होती है? इंस्ट्रक्शंस एंड डेटा. दिस मीन्स प्रोग्राम एंड ऑपरेंड. ये दोनों, these two instructions and data are stored in memory. Are stored in memory. See in the slide we have a diagram of memory size of 4096, and this memory is divided into two parts. One part is used to store instructions or program, and second part is used to store data, okay, or operand. Clear? And remember one thing, we always in computer architecture, जितनी भी हम examples लेंगे memory के related, we always use the memory of size 4096 into 16. 4096 into 16. What does it mean? This means our memory is of size 4096. Means we can store 4096 words in memory. 4096 into 16. This means 4096 words. इतने words memory में हम store कर सकते हैं. And this memory is divided into two parts. One part is used to store instructions. Second part is used to store data. Clear? And memory size हमें पता चलेगा कितना है 4096 words we can store in memory. What is 16? 16. The 16 is the size of the word. 16 is the size of the word. Suppose one word is of 16 bit. Our memory size is 4096. Means we have 4096 words we can store in the memory. And each word is of 16 bit. Each word is of 16 bit, numbered from 0 to 15. In this way, we can represent a memory word. In this way, we can represent a memory word. Yes, Tamanna. Unmute karo.
Sir, please repeat. 4096 is used for words.
Okay, okay. Listen one thing. We, in computer architecture, we use a common example of memory size, which is of 4096. 4096 is the, मतलब कि 4096 words we can store in memory. का मतलब ये है, का size है, memory का size कितना है? 4096 words हम memory में store कर सकते हैं. And each word, हर एक word जाइए, suppose करो ये एक word है. It is of 16 bit. It is of 16 bit. ये 16 bit का ये हमारा एक सेल है. 16 बिट्स इसमें स्टोर होंगी 0 to 15. And this instruction, this 0 to 15 format, instruction format is divided into various parts. The instruction code part is divided into various parts. One is डेटा का एड्रेस हो सकता है, डेटा का एड्रेस इसमें हो सकता है. सेकंड पार्ट may define operation, what operation we are performing on data, or it may be a data itself, or it may be a data itself. ठीक है? So this part 0 to 15 instruction is divided into various parts. Here we will divide, in journal we will divide it into 0 to 12, 0 to 11, 12 to 15. This means 0 to 11 bits represent address. The instruction format, one instruction represents 0 to 11 bits represent the address, and 12 to 15 bits means 4 bits represents operation code. Okay. The instruction, the one word is of 16 bits 0 to 15, which is divided into two parts. First part is address part, which is the operand address. का address होगा operand का address. Rahul, we just consider an example of 4096. It's just an example. ये एक एग्जाम्पल है जो हमने 4096 मेमोरी के लिए, ज्यादा भी हो सकता है, बहुत ज्यादा आजकल तो बहुत साइज होता है मेमोरियों का. ठीक है, we just taking an example. Okay, we just taking an example of 4096 memory size, and each word of the memory is of 16 bits, which is represented by 0 to 15. And this word is divided into two parts. First part is the address, that is the address of the data. कि हमारा मेमोरी में डेटा कहाँ पर पड़ा है जिसके ऊपर हमने ऑपरेशन परफॉर्म करना है. सेकंड पार्ट इज द ऑपरेशन. ऑपरेशन मींस ऐड, सब्ट्रैक्ट, क्लियर, शिफ्ट, etc. These are the operations which we will perform on data. Okay, so this address is the address of the data and the number of bits of operation code. अब हमें कैसे पता चलेगा कि ऑपरेशन कोड की बिट्स जो है वो 4 होंगी, 6 होंगी, 8 होंगी या 3 होंगी? It depends upon the number of operations which are available in the computer. Number of operations which are available in the computer. If we have, suppose if we have 4 operations, then this means number of bits is 2. 2 के 4 combinations बनते हैं ना, 0 0 1 0 0 0 0 1 1 0 and 1 1. This means this represents 4 operations. Okay. Yes. अब एक और important चीज है. The important thing is how we decide 12 bits for address. हमने बोल दिया जी 0 to 11 means 12 bits for the address and 4 bits for the operation code. How? Listen. If I write 2 raised to power 12, that is equal to 4096. Calculate कर सकते हो आप. 2 raised to power 12 is equal to 4096 and the power is the number of bits for address. हमारा ऑपरेंड डेटा कहाँ पर पड़ा होगा? मेमोरी में. उसको एक्सेस करने के लिए हमें मेमोरी का एड्रेस चाहिए. वो एड्रेस कितने बिट का होगा? 12 बिट का. ओके, the address bit is of 12 bits. Clear? Yes, Inder.
सर मींस कि 2 raised to power n जो है, मतलब कि n जो है वही हमारा
एड्रेस बिट्स
साइज
होंगे. यस यस,
साइज ऑफ द कैरेक्टर होगा.
बिल्कुल वो एड्रेस बिट्स होंगी डेटा की.
सर मींस कि हम n की वैल्यू इंक्रीज करें तो एड्रेस भी इंक्रीज.
क्या? हेलो हेलो.
अगर हम n की
n की वैल्यू इंक्रीज बोल रहे हो आप?
2 raised to power 4. सर
आपकी आवाज नहीं साफ आ रही है.
n की वैल्यू 14 raised to power 4.
फिर उतना ही आपका मेमोरी का साइज इंक्रीज हो जाएगा. 2 raised to power 14 करोगे ना तो मेमोरी साइज इंक्रीज हो जाएगा. 4096 से ज्यादा हो जाएगा वो. हमारे पास साइज कितना है? 4096.
यस सर.
इसलिए 2 raised to power, हाँ वो ये है कि अब 2 raised to power 14 करोगे तो उतना मेमोरी का साइज बढ़ जाएगा. और 14 योर्स एड्रेस बिट. ओके.
यस सर.
अब जल्दी से एक चीज देख लो. ये चीज, इस फॉर्मेट को देखो. लुक एट दिस फॉर्मेट. 0 to 15, 0 to 11 bits represent address and 12 to 15 bits represent our operation code which we are performing on data. Now if this part, the second part of the instruction format is of data, if it is data, then the address is called immediate address. Then the address is called immediate address. What does it mean? This means हमें data के लिए memory को access करने की जरूरत नहीं है. Data is given in the instruction itself. If the second part, first part is the operation code. Instruction format का first part is the operation code. Second part, if the second part of the instruction is data, अगर यहाँ पर data given है, then we no need to access the memory. Then this type of address is called immediate address. That is called immediate address. उसके लिए हमें क्या है, मेमोरी को एक्सेस करने की जरूरत नहीं है डेटा के लिए. डेटा हमारे पास डेटा कहाँ पर है, इंस्ट्रक्शन के बीच में ही है. ओके, दैट इज कॉल्ड इमीडिएट एड्रेस. नाउ सपोज द सेकंड केस इज इफ इट इज द एड्रेस ऑफ द मेमोरी वेयर द डेटा इज प्रेजेंट. इफ it is the address of the memory where the data is present, that is called direct address. Then it is called direct address. Then it is called direct address. Clear? Suppose अगर यहाँ पर किया 435, this is 435 and here we have a data if it is data, then it is immediate address. Then it is called, if the data, second part of the instruction is the data, then it is called immediate address. This means we no need to access the memory for accessing the data. Okay, the data is present in the instruction itself. But the second case is if it is address of the memory, address of the memory. Suppose it is 1, 2, 3, 4 and this is 1, 2, 3, 4. This is the address of memory where the data is present. This is 04 is the data. This 04 is the data. Means in the instruction we have given memory address where the address is present. That is called direct address. Directly मैं operand का address instruction में given है, तो that is called direct address. Second case हो गया. Third case is if the second part of the instruction is the address of the memory and here suppose 1, 2, 3, 4 is the memory address and this location we have another memory address. Suppose this is 3, 4, 5 here the operand is present. So this means, what does it mean? This is called indirect. हमें और डाटा का ऑपरेंड का एड्रेस इंस्ट्रक्शन में डायरेक्टली गिवन नहीं है. अगर यहाँ पर ऑपरेंड का एड्रेस होता तो दैट इज डायरेक्ट एड्रेस. इफ वी हैव, अगर इंस्ट्रक्शन में मेमोरी का एड्रेस है, उस एड्रेस के ऊपर एक और एड्रेस है, उस एड्रेस के ऊपर वो ऑपरेंड पड़ा है, तो दैट इज कॉल्ड इनडायरेक्ट एड्रेस. इसको हम क्या बोलते हैं? इनडायरेक्ट एड्रेस. नो सी एट द, अब नो वी, हमें कैसे पता चलेगा कि कौन ये वाली जो इंस्ट्रक्शन है दैट इज डायरेक्ट और इनडायरेक्ट है? फॉर दैट पर्पस द 15 bit of the instruction format is the mode bit, that is represented by I. 15 bit is the mode bit. If it is 0, then we have, if it is 0, we have direct address. This means the address which is given in the instruction is the address of the operand. Okay. If it is 1, then we have indirect address. This means the address which is given in the instruction is the address of the memory where we have another address, and at that address we will get the operand. That is indirect. If bit number 15 is 0, then the address in the given in the instruction is the direct address. If the bit number 15 is 1, then this means जो address given instruction में वो directly indirect है. Look at the slide. we have an instruction 0 add 457. 457 is the address of the memory where the operand is present. This is our instruction. Okay, the 15-bit number is 0. The operation is add. 457 is the address. 457 is the address where the operand is present. This is direct. Okay, address directly given, that is operand. At that address we have operand. Now the second case is here bit number 15 is 1. The operation is add. We have 300 address. 1 means indirect. इसका मतलब क्या है कि जो 300 है ये मेमोरी का एड्रेस है, इसके ऊपर एक और एड्रेस है 1350. 1350 के ऊपर क्या है? ऑपरेंड है. And this operand is added with accumulator and result is stored in accumulator. Okay. Indirect, this address is the address of the operand and this operand is added with accumulator. Add operation भी perform करना है, तो ये ऑपरेंड और एक्यूमुलेटर रजिस्टर में जो डाटा पड़ा दोनों ऐड हो जाएंगे, रिजल्ट एक्यूमुलेटर में ही स्टोर हो जाएगा. इन डायरेक्ट केस 457 इज द इफेक्टिव एड्रेस. व्हाट इज इफेक्टिव एड्रेस? इफेक्टिव एड्रेस इज द एड्रेस ऑफ ऑपरेंड. ओके. इन केस ऑफ डायरेक्ट एड्रेसिंग 457 is the effective address and in case of indirect addressing the 1350 is the effective address. Okay, now sorry students, I am going to launch a poll 2. So you have 5 minutes. इसको जल्दी से कर लो. Just theoretical questions, not any calculation type question. So make it fast. If you have any question, जो लास्ट टॉपिक है ना, ये नेक्स्ट लेक्चर में स्टार्ट करने से पहले ये मैं आपको रिवाइज करवा दूंगा. ओके, डोंट वरी. इसको एक बार पढ़ना, समझना. अगर नहीं समझ आएगी तो मुझे बता देना, मैं आपको ये रिवाइज करवा दूंगा. वैसे मैं रिवाइज कर दूंगा. सो हरी अप, आई हैव लॉन्च द पोल 2. तो क्वेश्चंस जल्दी जल्दी इसके जो है वो क्वेश्चंस करो. The student, the first question is an instruction. The address part points to the address of the actual data. The addressing mode is called, what is called? अगर हमें instruction में ही address given हो तो कौन सा address कहते हैं उसको? Direct, indirect और immediate. Operation of memory transfers are, memory के ऊपर कौन कौन से operations perform करते हैं हम? I have told you. Which operation is extremely useful in serial transfer of data? Serial transfer of data के लिए कौन सा operation perform करते हैं? Serial transfer of data के लिए कौन सा operation? Logical, arithmetic, shift. तीनों में से कौन सा है? एंड ये गलती से एबीसी डल गया है, तो इसको डोंट कंसीडर. ग्रुप ऑफ बिट्स दैट टेल द कंप्यूटर टू परफॉर्म स्पेसिफिक ऑपरेशन इज नोन एज इंस्ट्रक्शन कोड, माइक्रो ऑपरेशन, एक्यूमुलेटर और रजिस्टर. क्या ऑप्शन है? अब जी अभी बताया थोड़ी देर पहले ही मैंने. आज स्टूडेंट्स अनम्यूट योरसेल्फ. You have any question? हेलो अनमोल चावला, अनम्यूट योरसेल्फ. अनमोल,
यस सर.
सुन रहे हो ना लेक्चर?
हाँ जी सर.
अच्छा, समझ आया आज का लेक्चर? देखो स्टूडेंट्स, ये इजी नहीं है, डिफिकल्ट सब्जेक्ट है, इसको थोड़ा साथ साथ में आपको पढ़ना पड़ेगा. अगर कोई डाउट है तो अपने क्लियर कर लिया करो साथ में. अंकुश कुमार, अनम्यूट योरसेल्फ. अंकुश,
यस सर.
हाँ जी, कर लिया आज का? पता चला टॉपिक?
हाँ जी सर.
ओके. मनिंदर सिंह, अनम्यूट योरसेल्फ. हेलो, मनिंदर. ओके स्टूडेंट्स, पोल मैं एंड कर रहा हूँ, एंड पोल कर रहा हूँ, ठीक है? टाइम हो गया, 5 मिनट्स ऊपर हो गए, तो गोइंग टू